Okay, this video is in regards to this component right here and these capacitors and this resistor, these resistors, and it has to do with these two circuits right here using the 555 timers. This one here with that button is a manual clock. This is the monostable one-shot circuit, and this timer down here, this 555 IC, is part of the reset circuit with the reset button right there. Now, what I wanted to show you here was that this manual clock and the reset clock, the reset system, works in conjunction with this IC and these capacitors and resistors. And I'll show you on my computer exactly what this circuit does. And but the reason I decided to add this particular chip and these components is for a very specific reason. Is because although the 555s can be wired as a switch debouncer for these push buttons and other type switches, it just doesn't completely eliminate, for example, on the rising edge of the clock of the button, when you let go of the switch, there's a possibility that the switch may bounce on the way up, and it doesn't eliminate that. And other things too. For example, if you were to push the switch and let's say I push it with my finger but I hold it down, if I hold it down, then the IC is constantly being re-triggered. It never has a chance to finish its timing cycle, because as soon as it starts its new timing cycle, it will have finished. And of course that presents a very big problem to the circuit, because it doesn't allow any type of pulses to enter the logic circuit that you're working with. So what I've done is I've added this component here, and what this component is I'm going to go to my computer. What that component is right here. It's right here. Now this is the monostable circuit that I'm showing you. This is the 555 timer, and that I see with the switch and the components is actually right here. It's actually an OR gate, and with a hex inverter, capacitor, and resistor. And the way this works is very simple. This circuit here, not only does it debounce the switch, but it debounces the switch on both the rising edge of the pulse and the falling edge of the pulse. And the way it does that is very simple, because on pin 2 on a monostable, it has to go low in order to trigger the output through the timing cycle between the components here, the resistor capacitors. So in order to keep it from triggering, you need to keep this high. Pin 2 has to be high. So without pushing the button, the B plus at pin number 8 here goes through the resistor into the OR gate, and that high is applied to pin number 2, so it stays high. The other side is assuming that that's high or low is irrelevant, because you already have a high signal coming in at one end of the OR gate, so the input here is always a high. Now as soon as you push that button, what happens is momentarily this part of the circuit right here becomes low, just for a second, and that low is also coupled with the low on here. So the output goes low momentarily, just momentarily. And what that does is that triggers the 555. But if you continue to hold this button down, that means that this input is a low. But what happens is the low that's applied at the inverter will be switched to a high output, because it inverts the signal here. And that high starts to charge this capacitor through the RC time constant right here. And after a few nanoseconds or microseconds, this capacitor will have charged high enough so that the high value on this capacitor is applied to pin 2, and that high goes through the gate to stop the timer from triggering. despite that you're holding this button down. And even though, if you hold this button down, even though there's a low here, this circuit automatically puts a high after a certain amount of time at the other input of the OR gate, and it stops the retriggering of the timer chip. Now, what this circuit does basically is it gives you a very clean one pulse trigger. That's it. Whether you hold the button down or you don't hold the button down, it's irrelevant. As soon as you hit that button, the IC gets triggered, but it gets triggered through the timing cycle between this resistor and this capacitor, but the trigger input goes back to high as soon as you push that, soon after you push that button, so that there is very little chance of re-triggering because of switch bounce inside of the switch. And this circuit actually works for both the falling edge and the rising edge of the pulse, whatever the switch is doing. So I highly recommend adding this particular circuit to the trigger input of the 555. You will get a much cleaner pulse input, and despite whether you hold the switch, it doesn't matter how long you hold that switch down or how soon you release it. Doesn't matter. Once it's triggered, the 555 will get triggered only on the initial pulse at the very start of the contact of the switch. That's it. Anything that happens after that is completely irrelevant, because then the rest of the circuit will take over and assure that the trigger input will be disabled after the initial trigger of the 555. So this is a highly recommended circuit. It works extremely well. It's very, very clean, and I just wanted to show you guys, if anybody's interested in putting this together or use this particular design in your project, you're more than welcome to it. And I found this for myself to be the optimum pulsing system, manual pulsing system. You can also use this for a reset, because on this part of my circuit down here on the not the A-stable, but I got to move this over a bit here to show you. That's basically, so that was the one shot, and this one here is, I'm using this one here as a reset, and I'm basically using the same circuit here, the OR gate, resistor, capacitor, and inverter, and with the switch. So basically that's all it does, okay? So there you go, and you guys can certainly put this together and try it for yourself. I highly recommend it, and if you can give me some feedback on what you think, and I'll be more than happy to discuss it with you. Okay, until next time, take care. Bye bye.